everyone, welcome back. In today's video, we're going to talk about logs and logarithmic functions. In particular, we are going to look at the following example. Log base 5 bracket x minus 3 plus log base 125 bracket x cubed plus 3x squared plus 3x plus 1 is equal to 1. So how do we specifically approach this? So what we are going to do is we need to recognize that right now the two bases of the two logs arguments are different. So we will try to make these two the same first. So how are we going to do it? So we need to recognize that 125 is 5 cubed. So we can write it as this. And then we need to recognize that this 3 can actually be brought in front of that based on log law, where log a to the power of bx is equal to 1 over b log base ax. So based on this law right here, we can simplify this to log 5 minus 1 over 3 and everything else. And then we need to recognize that this 1 over 3 here is not really favorable for our calculation whatsoever. So what we should do is multiply 3 to each term so we can get rid of this fraction. So we will have 3 log 5x minus 3 plus 1 here log 5, and the argument stays the same. And then on the right side of the equation we will have 3 because 1 multiplied by 3 is 3. Now we can move this 3 up to the exponent because we need to recognize since we have two same base logs and we have a plus in between them, we can apply the log law where log AB AM plus log AN is log base AMN. So since it's a plus sign in between, so we can multiply the two arguments, but they must have a 1 coefficient. And how can we move this exponent 3 here? Is we can utilize this log law where when log A b times log ax is log base a x to the power of b. So we can do log base 5 x minus 3 cubed plus log 5 x cubed plus 3x squared plus 3x plus 1 is equal to 3. And then based on the multiplication log rule right here, we can do log base 5 x minus 3 cubed x cubed plus 3x squared plus 3x plus 1, which is equal to 3. And then, because it's log 5, it means 5 to the power of 3 is equal to the argument right here. So we can do x minus 3 cubed x cubed plus 3x squared plus 3x plus 1. They all stay the same. It's equal to 5 to the power of 3, which is equal to 125. And then this is the probably the trickiest part of this question. So we can recognize that this whole argument here, x cubed plus 3x squared plus 3x plus 1, if we are going to brute force this question by expanding every single term out in these two brackets, it's going to be fairly complicated and it will result in a 6th power polynomial, which is not really ideal for problem solving. So what we should identify is that this particular term right here is equal to x plus 1 cubed. So if we do this, it's going to make the whole problem much simpler. So how are we going to do it is that we're going to do x minus 3 cubed times x plus 1 cubed is equal to 5 cubed. And we can see that on the left side, we can write as x minus 3 x plus 1 bracket cubed is equal to 5 cubed. And if we take a cube root on both sides, like this, we can see the result will simply be x minus 3, x plus 1 is equal to 5. And then we can expand this out. We will have x squared minus 2x minus 3 is 5. X squared minus 2x minus 8 is 0. And then we would have x minus 4, x plus 2 is equal to 0. And based on zero product law, we would have the first possibility is that x minus 4 is 0, then x is equal to 4. And the second possibility is that x plus 2 is equal to 0, then x would be equal to -2. So these are the two preliminary possibilities of the solution we could have for this particular question. Now, we would go back to the original question, and we can see that the domain restriction for these two would simply be both of these need to be greater than 0. Therefore, we would have x minus 3 is greater than 0 and x would be greater than or equal to 3. And based on this reason, we can eliminate this option right here because this is out of domain, which leaves us with only one possibility here, which is x is equal to 4. Therefore, we can say the solution of this question is x is equal to 4, which is reasonably within the range of the domain. So this is how we can apply multiple different log rules to solve this seemingly complicated and hard question. And usually, students are attempting to expand every terms out, which is not the most ideal way of solving this question. I hope this is helpful for you to understand how we can apply different log rules to real questions. Thank you for watching.